It all starts with computer science, that is CS, which is behind all computing systems. It is related to what computers can do and how they do it. Key components include data structures, algorithms, software design, logic and computation. Computer science, or CS, provides the language, mathematical model, operating systems and core logic that allows any piece of software, including the most complex AI, to function and run. It is basically the how to build the machine part of the equation. Artificial intelligence. AI is a major branch of computer science, specifically focused on creating machines that can mimic human intelligence, including capabilities like perception, learning, reasoning, language understanding, and decision-making. While computer science is about how to build the machine, AI is about making the machine smart. It is a set of technologies designed to enable computers to perform tasks that typically require human cognitive abilities. Key differentiator is not all computer science is AI. Example, programming a simple calculator is CS but not AI. However, all AI is built upon computer science. Machine learning. ML is the most successful method for achieving AI. It is a subset of AI that focuses on building systems that can learn from data. It uses data to identify patterns, make predictions, take decisions, without being explicitly programmed for every scenario. The goal here is to enable computers to improve their performance on a specific task through experience that is provided in form of data. Traditional CS is like writing 1,000,000 lines of code for every possible rule. ML is showing the computer 1,000,000 pictures of a cat, and it learns what a cat is on its own from the data it was provided. Key differentiator is, if AI is the goal of making the machine smart, ML is the process involved. By learning from data. Deep learning, DL, is a specialized subset of machine learning. The deep part refers to its multi-layered structure, which is a complex web of algorithms called neural networks. Deep learning doesn't just look at a whole picture to understand cat. Instead, it processes through its many network layers, building its understanding step by step. Layer 1, learning starts with the most generic features, like basic lines, edges, and shapes. In Layer 2, these basic shapes are combined to form specific components, like whiskers, ears, and eyes. Layer 3, and further layers, map and combine all these specific components together. Finally, all the data from the previous layers are combined to conclude that this combination of shape, whiskers, ears, and eyes perfectly maps to the concept of a cat. It is this hierarchical self-taught process that makes deep learning so powerful and allows it to handle massive complexity. Key differentiator is, traditional ML often requires a human to perform feature engineering by manually telling the model what specific features in the data are important. Example, look for the whiskers and tail on a cat. While in deep learning, it automatically performs feature extraction. It learns the features on its own. Generative AI is a cutting-edge subset of machine learning, specifically deep learning, that focuses entirely on creating new, original content in the form of text, images, video, audio, or code, based on the patterns it learned from its training data. Its goal is to move beyond prediction and classification and go further into imagination and creation that is similar to, or often indistinguishable from, what a human might produce. If traditional ML predicts that an email is spam, generative AI goes a step further and can write an entire email for you. Key differentiator is, all generative AI involves deep learning, but not all deep learning systems are generative AI. The large language model, LLM, is a specific, powerful type of generative AI that is solely focused on understanding and generating human language, like text, code, or any sequence of words and symbols. They are the computational engines behind chatbots like Gemini, ChatGPT, Claude. Before LLMs, there is NLP. Natural language processing, NLP, is the branch of artificial intelligence that gives computers the ability to understand, interpret, and generate human language, in form of speech or text. LLMs are simply the most advanced tools currently sitting inside the NLP toolbox. An LLM is a supreme statistical predictor that is trained on trillions of words of human language. It constantly calculates and predicts the most probable next word in any sequence. It doesn't think like a person. It simply repeats this high-speed prediction process thousands of times to generate fluent, coherent text, code, and conversations. The large refers to the immense scale, measured by the trillions of parameters or adjustable settings an LLM has. The more the parameters, the greater the detail, nuance, logic, and context it can capture from the training data. Which is why LLMs exhibit advanced, unprogrammed, complex abilities like summarization, coding, and reasoning. An LLM is a complex deep learning neural network built on the transformer architecture. This foundational model uses a key feature called self-attention, a specific type of attention mechanism that allows the LLM to look at all the words in a long sequence and determine which words are most relevant to each other. This is the crucial breakthrough that enables LLMs to remember context and maintain coherence throughout long conversations. All LLMs are generative AI, but not all generative AI models are LLMs. An LLM generates text. An image generator like DALL-E is generative AI, but it is not an LLM because its primary output is a picture, not language. LLM is exclusively a text-to-text system. It is designed to only consume text, your prompt, and only generate text, its response or code. But the newest, most advanced models, called multimodal or LMMs, can handle text, images, video, and audio. When an LLM is given the ability to process text, plus non-text tokens from images, video, audio, it stops being a language model and becomes a multimodal AI or a large multimodal model, LMM. Multimodal AI is an evolution of the LLM. It is an AI system that can seamlessly understand, process, and generate information from multiple data types simultaneously, such as text, images, audio, and video. It uses an encoder to convert an image or video into a numerical language called tokens that the LLM understands, allowing it to fuse the image or video data or the non-text token with your text question and give you a comprehensive answer. Agentic AI is an advanced framework that can autonomously set goals, plan multi-step actions, use external tools, and execute tasks with minimal human intervention. The agent's core reasoning is powered by large language model, LLM, or the latest, large multimodal model, LMM. This model acts as the brain, providing the logic to break down a high-level goal, plan the necessary steps, and interpret the results of its actions. The agentic framework adds the body, the ability to execute steps, memory to remember past actions and maintain long-term context, and tools to connect to external systems like web search, coding environments, or APIs, and a reflective loop to self-correct plans when obstacles arise. This creates a system that operates on a goal-oriented basis, assigning a mission and expecting a complete, real-world outcome. The entire Gemini family of models, including 2.5 and 3.0, are classified as large multimodal models, LMMs, because they were built from the ground up to natively handle text, images, and audio. However, Gemini 3.0 marks a generational leap in the depth of its multimodal reasoning and agentic AI capabilities, making it the current flagship of the LMM class. Prompt engineering is the art and science of designing and refining the prompt or the input instruction to guide a generative AI model towards generating the desired high-quality and useful output. A simple, vague prompt, example, write about cars, leads to a generic, average, and useless response, because that is the most statistically probable output. Prompt engineering provides the intent, context, and constraints to force the model to move beyond the statistical average and give you the specific targeted answer you need. Key techniques to control the output. Role-playing. Give the model a persona. Like, act as a researcher. Task and goal. Define goal like, who is writing a white paper on? Constraints and format. Set constraints like, the final output must be exactly 5 bullet points. using a formal tone. Chain of thought is a specific, advanced prompt engineering technique where the user explicitly instructs the model to use its step-by-step reasoning abilities for complex problems before presenting the final answer. Let me know your thoughts about this video in comments. See you in my next video.